Hi folks, and welcome back. What we'll be looking at in this lecture is how to find the length of a curve. And by that we mean, given any continuous function, we want to find the length. In other words, how many feet, inches, units it would take to traverse the curve, walking along the curve from point x equals a to x equals b. This is a pretty cool concept, and it's actually fairly easy to analyze. And there's some interesting problems that you'll get to work on when you do your homework questions. So just as when we were looking at areas, what we're going to do is take this interval from A to B and break it up into n subintervals. And what we'll do, if you think of a maybe just a blow up like this, and this length right here is delta x, what we're going to do is approximate the actual length with, we're going to approximate the actual length, which is this, with this length. And a little bit of a bigger blow up will show us exactly what's going on. So here's the picture that we're looking at. Imagine that we're looking at just one of those partitions. And so this distance measured along here is delta x, and this distance measured along here is delta y, and what we'll do is we'll call this distance, which is the hypotenuse, delta s. And so what you see is we're letting delta s approximate the actual length along the curve. And it should be pretty clear that if delta x gets smaller and smaller, delta s and the actual length are pretty much exactly equal. So it shouldn't be very difficult for you to understand that delta s is equal to the square root of delta x squared plus delta y squared. And again, I'll leave out a lot of the steps, but being bright boys and girls, you should be able to figure out that this is equivalent to this expression. Delta y over delta x, quantity squared, times delta x. That should be fairly easy for you to verify. And so the length is approximately equal to the sum of all these delta s's. And furthermore, the length will exactly equal the sum of all these delta s's as n goes to infinity. So this is just like what we have been doing in the past with areas. So we'll go on to the next page and we'll see exactly what this looks like. So here's what we know. We know that if we let n go to infinity, in other words, that's the same as saying, let's write it, delta x goes to 0, the delta s and the actual length will be exactly the same. And so this limit is simply going to, remember that delta s is this, so the length is going to equal simply the integral from a to b of the square root of 1 plus dy dx squared dx. And that's our expression for the length of a curve from A to B. So, as always, let's look at a couple of examples to help understand this. So here's a simple example and an interesting one. What we're looking for here is the length of one arch, in other words from here to there, of the sine graph. Now, what we've seen is that the length is equal to the integral from 0 to pi of the square root of 1 plus dy dx. Well, dy dx is cos of x. So this is cos squared of x dx. And it should be worth noting, number one, that this is not an easy integral to do by hand at all. Number two, a lot of the questions that we'll be looking at from here on simply ask you to write out the definite integral expression for what we're looking for. So volumes will be like that, length of curve will be like that. You can turn this over to your graphing calculator with a CAS built in, and what you'll learn is that this length is about equal to 3.8202. Quite likely an irrational number. Okay, let's try another one. Okay, so let's look at this example. What we want to find here is the length of the curve, sine of x minus x cos of x, sketched here, over the interval 0 to pi. So just to make sure we get it, dy dx turns out to equal x times sine of x. And so just using our formula, this length is equal to the integral from 0 to pi of the square root of 1 plus x times sine of x squared dx. And as before, we either stop here, or if we're given license to use our graphing calculator, we find out, I think, that this is about 24.6984. All right, so that's it about length. Pretty cool, and have fun doing some problems. See you next time.